Homework 7. Let's go for it. It's going to be a long one. Over here, we are classifying these functions as growth or decay. So if I refresh a couple of things, I want to remember that I have my exponential function form, and it's helpful to even rewrite that. We're going to do that here. So y equals a times b to the x. And I know that that's an exponential function because I have an exponent as a variable. Now remember, if b is greater than 1, so maybe I'll make a little note for myself. If b is greater than 1, then I'm going to draw an arrow. That means we have growth because it's growing. We have a whole number that's growing exponentially. If b, so that term that's taken to the exponential power, is less than 1, then we know that is exponentially getting smaller. Okay, so let's look over here. So first of all, we are just classifying these functions. So I know here that we have an example. Well, first of all, b, and if it helps you to identify that b is a quarter, and that is less than 1, that means that this is an example of exponential decay. Okay. Maybe if I come back a little bit. If I look at number 2, this might be tricky. So b here equals 7 halves. Is 7 halves a fraction? Well, it's in fraction form. It's an improper fraction. But 7 halves is actually greater than 1. So this is still going to be, even though it looks like a fraction, it's still be considered growth. Okay. Now for number 3, again, I'm just designating these as decay or growth. If I look at b equals what? Well, remember, b is what's taken to the exponent. So b is 5. So I still have growth here. Don't be confused by the a value, which is a third. Okay, so that's still growth. So down here, now I'm going to start graphing these functions using a table. So function table. And then I'm going to identify the characteristics over here. So let's go over here. I'm not going to do all of these, but I'm going to do what I can. So right here, I'm going to make a function table. So I have an x and y value. So what this means is I'm going to choose some values for x, and you're going to see that I always choose the same values. Sometimes I like to add a 3 because I like to see if I need another value or not. So these are the ones that I've just decided. These are good standard ones whenever you're trying to plot out or use a function table. These are great ones to start with. So remember what this means is, and then I like to use the space over here for my work. So, and I like to always start with 0 because I like starting with 0. So if I think about 0 here, I have a half to the 0th power. Now remember, anything to the 0th power is 1. Great. Okay, so now I have 1/2 to the first power. 1/2 to the first power is 0.5, or a half. It's always that same number. Then I need a sharper pencil. Then I have 2. So I'm going to have 1/2 to the second power. And I could even keep going if I wanted to. So I'm just writing out my work here, okay? I'm showing you my work. So I have 1/2 to the second power. Now 1/2 to the second power means 1/2 times 1/2, which means 1/4, which is 25 cents, which is a quarter. Now, if I think about it, I have 1/2 to the third power. Isn't that 1/2, 1/2, 1/2, all multiplied together? 2 times 2 is 4, 4 times 2 is 8. Right, so now we are up to 1/8. Okay, and I can do the decimal equivalent. So now I have some negative exponents. Oh, these are always so scary. So I think about what this means. So if I have 1/2 to the negative first power, that means that I have 2 to the first power. And what is 2 to the first power? Well, 2 to the first power is 2. Now I have 1/2 to the negative second power. And what does that mean? Well, it means 2 to the second power. So I now have my output as 4. So again, I chose these values. I substituted these x values, which are my domain or all real numbers. I could come up with any number to use as my exponent, any real number. I could put it through my machine, and then I could compute, well, what's my output going to be? So that's my input-output table, my function table, if you will. And now I can go ahead and graph. So here we go. If I, first of all, I always like to start with my 0, 1. So I'm going to go ahead and do that. So if I think about my 0, 1, I'm going to go over 0, I'm going to go up 1. And that is going to be my intercept, my y-intercept. And I could even go ahead and put that in here. And I could put it in as coordinates. That's my y-intercept. So whenever x is 0, y is 1 in this case. Okay, so now going back to my coordinates. So these become coordinate pairs. So if I look to my second, I'll go to maybe this one. Let's go this one next. I'm going to go over 1, and I'm going to go up 1/2 or 0.5. Then, hopefully you can see that a little bit. And then I have 2. If I'm going to go over 2, I'm going to go up like 1/4, right? If I go over to 3, I'm going to end up really, really small, but it's again not really touching that x-axis. It's kind of hovering over it. So that should be a clue as to what that is. But so now I'm going to go back here and I'm going to look at my other values. So I have another ordered pair. I have -1, comma 2. So I'm going to go -1. I'm going to go up 2. And then I have -2. And then I'm going to go up 4. So 1, 2, 1, 2, 3, 4. Okay. If I added a -3 here, maybe you could even see the pattern. Oh, 1 times 2 is 2 times 2 is, well, we're going to have, if I do -3rd, it's going to be 1 over, sorry, I didn't mean that. It's going to be 2 to the 3rd power, which is 8. So these are exponentially, if you see it, going up. So I'm going to add one more value to this because I want to. So I have my 2, comma 4, and I'm going to do my -3, and I'm going to go up 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Now this should give you a clue as to, first of all, it's not a linear equation. It's a little loop-de-doo. Okay. And it's suddenly we have this dramatic rise here. So if we think about this, is this something that is growing? If I start here, is it growing? Well, no, it's actually getting smaller. So we had this kind of high number, and then suddenly, right here, it starts to get really low. And if I look at my b value, remember b here equals 1/2, and it's less than 1. So that means that this is a decay. My domain are my x values, right? So anything that I put into this table, I can put in all real numbers. My range is really, what kind of outputs can I have? What's the range of outputs that I can have? Well, if I look at this, are there any values? Like, is y going to be less than 0 here? Well, it doesn't fill any of this in. So, but it looks like it's going to keep going here on and on forever, but in the positive territory. So all of my range is going to be greater than 0. So again, if I look back at my y values, even though this is going to get exponentially smaller, it's never going to be a negative number. It's never going to be below 0. Okay. And my asymptote is going to be that y equals 0. It's just hovering on that 0. Okay, let's do maybe one more. So over here, again, I'm going to set up another function table, and I'm going to try to show as much work as I can. If I analyze this form right here, it looks like Well, I have an exponential value here. So here, let's go ahead and put these possible values over here. Here are my input values. And then I'm going to put them through my machine, and I'm going to show my work, and I'm going to figure out what we're going to do next. So I have now, if 0 is x, so this means I have 3 to the 0th power, but now I'm subtracting 5. So I have 3 to the 0th power, which is anything to the 0th power, is 1. So this equals 1 minus 5. So I suddenly have a negative 4. That's going to be my y-intercept because x is 0. Okay. So if I go up to 1, so now I'm going to have 3 to the 1st power. Remember, these exponents I'm just plugging in for x, my x values that I created, and I got it from my exponential form up here. So if I have 3 to the 1st power minus 5, don't forget that I have to subtract 5. I have 3 to the 1st power, which is now going to be 3 minus 5. 3 minus 5, negative 2. Now I have 3 squared minus 5. So again, here's my work. And then that's going to become 9 minus 5. And that, we finally have a positive value over here. So now I have some negative exponents, which, you know, can be very tricky. So now I'm going to show my work. I have 3 to the negative 1st power. And then I'm going to subtract 5. So 3 to the negative 5th power is, well, is going to be 1/3 minus 5. 1/3 minus 5 is actually going to be a negative 4, and that decimal. So I've got lots of negative numbers here. And then I'm going to do one more here. I'm going to do 3 to the negative 2nd power, which again means 1 over 3 squared, which means 1/9 minus 5. Well, 1/9 minus 5 is going to be close to 5, but not quite. It's actually going to be that. If I kept going, am I ever going to get below negative 5 here? Well, that's a great question. So that's a lot of work. Now let's go over to the graph. So I'm going to start with my, if I zoom out a little bit, I'm going to start with my 0 and my negative 4. Because that's my, I actually liked putting boxes around my y-intercepts. And just because I'm thinking about it, I'm going to do my y-intercept here. So it's negative 4. So remember, if x is 0 here, that automatically means that the second value, the y, is the intercept. Okay, so let's graph this one. So again, I'm just going to take these ordered pairs. So let's go for, let's see, 1, negative 2. Let's go over here. So I'm going to go to 1. So x is 1. And I'm going to go down 2. 1, 2. Okay, so that's the second point. Now I'm going to do this, I'm going to go 2, 4. So if x is 2, 1, 2, now I'm going to go up 4. 1, 2, 3, 4. Oh, wow. Notice that's a kind of a high jump here, like a ski jump. So now let's go to the negative territory. So I have negative 1, comma, negative 4, a little over half, negative 4.5. So I'm going to go negative 1, 1, 2, 3, 4, and about a little more over half, right? And then I have negative 2 and then negative 4.8. So negative 2, 1, 2, and then negative 4.8. It's going to be like right there. It's going to hover, right? And then I could keep going. I could keep going. Whoa, look at how high that's going to go. And then this is going to hover right on this line, if you think about it. So that, again, is the asymptote, right? It's not going to be lower than this number, if you think about it. It's not going to be that either. So the y, the asymptote, is where it really hovers. It's going to be negative 5. And if you think about the range or all the outputs, right, and the domain, again, I could put any number in, right? So again, I just thought up these, but I could put any real number in, if you think about it. So these are just all real numbers that I could put into my little system here, my function. And the range, remember, is all the output. So if I look back at my graph, what kind of range? So what kind of output do we have? Well, it's not all real numbers because remember, this whole area does not work. So the asymptote and range are very related. The range has to be basically anything, all of these numbers, greater than -5. Okay? So y has to be greater than -5. Okay? Let's do one last together. Woo. This is some stuff, all right? So again, I'm making my table. I'm gonna pick my same values because I feel safe with these same values, and I'm gonna prepare my little workspace. Okay, so now I have a 2x plus 1, so it's an exponential function. Great. I'm gonna go for 0. So if I put 2 to the 0 plus 1, well, anything to the 0 power is what? 1. So this means 1 plus 1, which is 2. Now I have 2 to, oh man, the light just went off again. Now I have 2 to the first power plus 1. Anything to the first power is itself. So 2 plus 1, which is 3. 3. Now I have 2 to the second power plus 1. Hopefully you see where this is going. 2 squared plus 1 is 4 plus 1 is 5. 5. Ugh, now I got these negative exponents. Oh man. So 2 to the negative first power. So I have now a half, you can see that, plus 1. Well, what's a half plus 1? Well, I can do that. 1.5 or 1.5. Hopefully you can see where this is going. 2 to the negative squared power is 1 over 4 plus 1. So it's really 1 1/4. So I think we've got enough ordered pairs to plot them in. Okay, so let's see. I like to box my y-intercept. So we've got y is going to be 2. So let's go over here. So I'm going to go ahead, 1, 2. I'm going to plot my y-intercept. And while I'm at it, I'm going to go ahead and go for it. I'm going to put my coordinates for my y-intercept. Great. First of all, let's go for, how about 1, 3? Okay, so we're going to go 1, 1, 2, 3. Okay, and then let's see, we have another one. We have 2, 5. That's our next ordered pair. 1, 2. 1, 2, 3, 4, 5. Okay, and I could keep going. Could I do one more? Sure. If I do 3, because I like to see the dramatic boom effect. If I add a 3, because I really just want to plot one more, because I just love it so much, would be 2 cubed, which is 2 times 2 is 4, 4 times 2 is 8, 8 plus 1 is 9. We've got 9. So let's go for 3, 1, 2, 3, and 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's a pretty dramatic shift right here, right? And then over here, I have -1. So if I come out a little bit more, if I have -1 and then 1.5 is going to be about here. Then I have -2, and I'm going to go up 1 1/4. So I'm going to end up getting smaller and smaller and smaller, and it's going to sit right on this beautiful 1 here. I'm going to do my little ski jump here. Okay. So does this look like, it looks actually very related to this. Oh, I forgot to add over here, this is growth. My apologies. If that one's growth, what do you think this is? It looks awfully familiar. Yep, it's growth. If I look at my domain, I can put any number into my little factory here. So it's all real numbers. My range, let's look at that range now. Well, my output, right? So basically, my y, right? All the y values that would make this true. Well, it's not all real numbers again because it's going to all sit on that 1, right? So it has to be greater than 1 or my asymptote. So again, they're very related. So here you go. That was a lot of work for a homework. I'm going to just end there because it is a lot. Good luck. We'll go over